Well, hi and welcome to my shop. While I continue doing some more things to this CB radio here, there's a lot more stuff I can do with this. Even though it appears to be working, I don't know, let's say a strong 75%, I still think there's a lot more stuff I can do here, and I want to explore some more stuff with this too. So I'm going to continue poking along with it. I've been looking at the some information in the service manual I overlooked, which we're going to take a look at in a second. But what might have caught your eye already is the antenna here, which looked a little more like this last time you saw it. Whoops, but now it looks like that. I just simply removed this piece here to discover what is inside. I've never looked at one of these antennas before, so why don't we start with this? Because this antenna was causing trouble. And what I mean by that, I don't need that under it, is well, for a little history, I've been dragging this antenna around with me for probably 25 years, and of absolutely no use to me. That wire was cut right here. I just had this in my collection of junk. Well, look out, now I need an antenna. I dragged it out, and one evening I spent quite a bit of time remaking the connection here, doing a real nice job on it. But when I connected, and everything indicates to me visually, and even now with the cover off, everything is fine with this antenna, wiring wise and connection wise and all that. But when I hooked this up to the CB radio and I clicked the SWR measurement, the needle just went right off, just went right over. Boom. So I thought, okay, something seriously is wrong with this antenna then. It must be either a total open circuit in the wire somewhere, or maybe a short circuit somewhere. And that's why I decided, because I need an antenna here to continue doing stuff with this radio. In fact, what we're going to look at in the manual actually calls for an antenna. It doesn't say make sure you've got a dummy load on the output. It says make sure the antenna's connected. So I really need one of these guys too. And besides, eventually I'm going to want to talk to those people in Alabama. I need a powerful beast like this thing here. So let's take a little bit of a closer look at this. There is evidence of corrosion on it, but I'm not so sure it's a serious thing. I'll just steal the camera from up here. Yeah, lots of snow coming down outside today, and apparently tomorrow is the real snow day. So again, the cable just comes in the bottom, feeds up into this connector here. You can see it's threaded. You can just undo this. This whole piece will come off. You can undo this top part. It comes off. That's what you got to do to get this plastic piece out. This plastic piece is nothing but a plastic piece. Looks fancy, but it's really not. It's just a plastic cover. It's got some rubber seals here and another one here to keep the water out, but you can see evidence of corrosion on all these connections here. Now, how they constructed this is kind of interesting. So we look at the coil, we can see, maybe if I just spin it around like this, look, there's a tap. This has basically got, what, 3 or 4 turns, depending upon how you count these, and then this has got 10, 15. Well, my gosh, what's happened? What? You know, I'm going to put him on camera here. Let's just give him a little bit. Peanut, come on over for a close-up. Come and show everybody your wonderful face. Come on, up here. Oh, I can't hold the camera still. We haven't got enough light down here, Peanut. Well, what have you come in here for, being so foisy? Okay. Clearly I'm going to be stuck having to leave in a moment, so I'll try to finish this antenna talk really quick. Okay. So, you can see that the antenna is tapped here. Let me just swing my cat light back here. So I looked very carefully at this tap, and what it is they've taken the wire. They haven't cut the wire here at this point. They've simply cleaned it off and soldered it to a pin, and the pin is going straight through the fiber tube, and you can see the back of the pin if you look in this other hole. That's the back of the pin. Now what's the pin contacting inside the fiber? Well, I got to guess that the center conductor, which is traveling up, I can't really see what's going on. I'm guessing the center conductor comes up and the pin strikes it. So at this point we have the center conductor connected here, right here. You can kind of imagine the signal is traveling up and away from this point, up this way and down this way. It encounters the ground here. So this part of the coil is just between the pin, or the center conductor, and the outside. Oh, Peanut, please. Come on, man. Can you give me a minute? I tell you what, 3 minutes. 3. See my fingers? 1, 2, 3. 3 minutes. I got 3 minutes. He's going to hold me to it too. So we look at the top, how the top of the coil is terminated. I mean, the bottom's obvious what they've done here. They've just soldered it to the outside. But the top also connects to a pin. You can see the back of the pin here. And I assume the pin is in contact or driven through this piece. I mean, this piece has to be connected somehow. You can't very well have an antenna without the antenna connected. So this must be encountering this pin. And I have to assume this isn't a continuous metal shaft all the way down through here. I just can't imagine this coil would be doing nothing then. And the last thing is, how much metal is inside this fiber sleeve? Is it something to do with the impedance of these coils? I have no idea. I don't know what's going on inside the fiber tube. So what do we got here? So we've got a signal comes from the radio, reaches this point here, travels through this coil to get up onto the antenna, and at the same time is going through this coil, shorted essentially, shorted out to the... Hey, there's still a minute left. A minute. Okay, so that's what's going on with the antenna. I don't think there's a darn thing wrong with it. So we're going to start by transmitting into this antenna, and we're going to check out what happens on the three-way CB tester. Three-way. Okay, Peanut, I'm coming for you. Let's go do what you want. Get out of my toolbox. What are you doing in there? Okay, I think Peanut the Wonder Cat is going to be happy now. I gave him a really good rub down. He's just outside my shop. Shh. So, I did some experiments here. I'm going to repeat now with this antenna. Maybe you noticed the antenna cable is connected straight into my signal generator. And I've got CB frequency, or, in the CB... Come on. What now? Must be a food bowl issue at this point. So I have this in the CB band, and what we're going to do is we're going to look at this on the SWR radio and see if we can spot some kind of resonance in this thing. Now, I can't imagine that there's some kind of sharp resonance to this, but it's got coils. The other thing too is I'm missing a major component of this antenna, which is a car. I need a car with this antenna sitting on it. Lastly, this is a magnetic grip antenna. So usually there's a large metal plate here with a pretty strong magnet on it. That magnet is sitting on an I-beam in my garage where I had this antenna stuck for a year or two, and when I pulled the antenna down, the magnet stayed up there. It's still up there. So these are all things that are wrong with this antenna, and maybe it's not so surprising that it's not working so well. Let's just take a look underneath here for a sec. As I say, I really need some kind of CB antenna. I don't know, maybe I'm going to have to whip one up somehow. So I don't think there's anything magnetic about this. Nope, of course not. Magnet is out in the garage. There's this tin foil. What is all that about? Well, I'm not exactly sure what's going on here. Maybe the magnet makes a metal connection, and maybe that... I can't imagine. You're supposed to put this on your car, and your car is painted, right? Well, I guess you would get a capacitive effect. Son of a gun, is that what they're doing here? that once you have that magnet plate here, which is electrically connected to this, which is electrically, I assume, connected to the shield, that the metal plate is making some kind of capacitive connection, if you like, to your trunk hood or top of your car. I guess this is really meant to be right on the top hood of your car. An alternative antenna is that I've thought about. I don't know if I talked about it or not, but let's get this guy standing up properly here. Come on, stand up, be proud. Come on, head back, chest out, shoulders back. There we are. Well, this guy has an antenna. It comes with this radio kit. This is an emergency kit. It's not meant to be, you know, your CB base station for talking to Alabama. But it does have its own antenna. Here's the connector for it. There's a long, skinny wire going to it. I'm guessing that the impedance of both the antenna and the output of the radio have been designed by the designers to match. It doesn't in any way have to be 50 ohms. Doesn't have to be anything that would work with this other radio, which is targeting a standard 50 ohm antenna line in that. So antenna and antenna line. So I don't know what to do here. That's basically the bottom line. Should I try to build? That'd be goofy. I was going to say, should I try to build my own dipole? Well, let's see. A dipole at FM antenna at FM frequencies, like 100 megahertz for FM radio. A dipole is about as wide as my bench here. So here we are down at 27, which is roughly a quarter. So it'd be 4 times the size. Four times the size. No, I'm not going to make a dipole antenna inside my house 4 times the size. But I'm really stuck here on what to do. So that's a problem. I will ignore it right now because it's a showstopper. And you know what? If your intentions are being destroyed by truth, you better just ignore the truth and carry on. That seems to be the way the world is working these days. Some parts of the world. You cannot let truth get in the way. Remember that. Okay. Now that I've finished talking truth to power, so I still have pretty good dummy antennas. I don't know why the instructions. Let's read the instructions. And it's calling for an antenna, but maybe a dummy antenna is an antenna. Dummy. Let's take a look at the instructions here. See if we get a little more confused. Okay, so I think I told a story a video or two ago about one of my teachers. Here's a test. Everybody read through it. The last line on the test was do nothing, just watch everybody else who didn't read through it. And while I'm telling you that story, I am failing to read through this manual. So although I understand why I should do it, I still didn't. So irony is running at 100% here. So let's do it now. So I kind of read through all this. No, I didn't. I never read this part. I skipped it. My eye skipped it. Maybe because of this time. I don't know why. But look what it is. Test equipment connections. It's actually a section here with statements on how to connect the equipment. I just relied on this diagram and the body of the instructions, wherever that is down here. So let's take a look at what this says. Connected test equipment is shown in Figure 3. Okay, Figure 3 is here. Okay, more or less did the same. Oh, let's just look at this briefly. The oscilloscope, which we're going to be looking at shortly, they don't actually show it connected to the output here. They show it using a pickup coil near coil L10. Pickup loop, they call it. So I've set things up similar to this, but I really don't know why you wouldn't just hook your oscilloscope down here to the output. I don't know the answer to that question, so we will carry on. You know, maybe I have an answer. Here's an answer. If you're going to hook your oscilloscope leads down here, and you're going to key this transmitter, you're going to have a very powerful signal here. Well, that's fine for seeing it on the scope, no doubt about it. But the problem is, it's in the scope lead. The scope lead will act as an antenna, because you have a powerful signal in the scope lead. Well, you just turn the sensitivity down on your scope. Look at all these other wires. They're very much showing them like pipes. Like this is all shielded cable, coax cable here. See, these ones, they don't show that way. And this one, this is a very, you know what? Now I understand why they're doing this pickup loop. Look at this, is a very particular thing. Let's see if I can find a sketch of it quickly. Somewhere, there it is. Look at this thing. This is an engineered loop using coax. What is going on here? Why do all this? What? Wait a minute. Oh my gosh, I never even noticed this. They want you to make all this up too. Oh my gosh, really? This is a transformer here? 27T. See, if you're working in a shop where you're going to fix this radio, just give you a little better sound here. If just one second. Hello. Okay, I was a little worried there. My voice wasn't being recorded. Okay, not sure what's going on. I'm never sure what's going on. There's too many things happening in the shop all at once. Get back to this diagram. I thought when I glanced at this, I was seeing this, and you connect the end here to your scope, and then this was something else I paid no attention to. Oh man, the irony of it all. Now I look at it. Oh my gosh, this is what they want you to build. What's this? This 2 wire, 3/8 iron core. Yeah, well, I was saying, if you are going to do this kind of thing, it's because you're running a shop and you fix this modular radio every week. People bring it in for you to fix. So you're going to put one of these together and bingo, you've got it. Here's the thing about it, I think. This is all shielded. So it's picking up a little bit of signal here. It's actually picking it up in this loop here. And then the signal is traveling in a shielded cable. I guess this is intended to contain the signal you're trying to get up to your scope from leaking out all over your shop. That's why they've done it this way. Oh my gosh, wow. In some ways it's a good thing I didn't look at that closely, or I wouldn't have done much of anything here. Okay, so where are we? So we're back here. Be sure to connect the 50 ohm antenna. It didn't say dummy antenna. So that's why I'm anxious to get that antenna working properly. Connect the DC VT to the junction of R64 papa to get relative indication of rectified PA grid voltage. Okay, and the reading is reduced by a drop across an adjacent resistor due to current flow in the VTVM. A relative indication of rectified power amplifier grid voltage. And this connection is made quite a distance from the electrical distance away from the tube itself. It's actually kind of way back in the circuit somewhere. And check this one out here. Connect DC voltmeter across 46, the 100 ohm meter shunt. Oh my gosh. So here it's declared very clearly what is going on, why they put a 100 ohm resistor in there. It's a shunt for the meter test, as I suspected. The part of the manual I read didn't say anything like this. Positive terminal, each volt read will represent 10 milliamps PA plate current. Hello, Jim. I figured this out, but it would have been a lot easier if I just read it here. And then this last warning here. Caution, meter is floating at supply voltage above ground. Metal cases of some VTVMs may be hot with DC. So you might remember I was going to hook up a VTVM to this to perform this test, and I decided no, I would hook up one of my multimeters because it's completely independent of ground, of power system ground or power system negative neutral wire, whatever you want to say. So okay, that's great. So I used appropriate caution and not following the pickup coil. I got my own pickup coil. It's a piece of crap in comparison to what they're doing here. But could be some of the test results I've gotten is because I have not followed precisely what they're recommending. what I'm really interested in this morning, along with the antenna, is these guys here, these modulation checks. It's easy to do, and I want to carry this out. And intentional audio peak clipping will limit the crest. So look at this, figure 6. So finally we find out where figure 6 fits in here. Shows output waveforms modulation 50 and 100, over 100%. And this equipment, intentional audio peak clipping, will limit the crests and valleys to about 90% modulation with sine wave input. With voice modulations, the valleys will be modulated to approximately 100%. So they designed this radio so a guy can grab that microphone and bark into it as much as he wants, and the most he's going to do is 100% modulation. He's not going to do this over modulation thing here. The other day I was listening to shortwave. I picked up a shortwave broadcast station, an international broadcasting station, probably 500 kilowatt or 300 kilowatt, like a big, powerful, legitimate transmitter, and they were over-modulating it, something terrible. And it was showing up all over the place on my receiver, and so it would be all around the world. So bad on them. They were doing this, not paying attention. But you know, I pick up a lot of shortwave stations where the modulation is way down, almost like this. You have to turn the volume way up on your radio to hear the guy's voice. So I don't want to be one of those guys. I want to be this guy right here. So I want to do this test. Now let's go back to figure 6, and they're talking about what happens when the audio level gets high enough that this clipping thing starts kicking in. Figure 6 turns out to be the mystery diagram up here. Mystery diagram, so mysterious, it's not even in this. Okay, the mystery diagram, this is half the manual to the other half. Let's go to the other half. There's the mystery diagram, figure 6. So what this is showing is if you have a sine wave going into the radio and you raise the level of the sine wave enough, you will trigger this clipping circuit, or you will encounter the clipping circuit. The clipping circuit will make the sine wave look like this. And that's keeping the modulation level from going over 100%. When tested with a sine wave, you will get this effect at 90%. I think that's what it was saying. Or you will see that effect at 90%. Okay, I don't need to go up and down through the manual here. I think we're ready to do a couple things. Let's do them. And I warn you once again, as I have warned everybody many times to watch my videos, I do a lot of wrong stuff in here on my way to getting it mostly right, but you know, this is not a course on how to tune up the CB radio. This is me trying to do it. Good luck to me. Hey, let's turn it on. I haven't had it on all this time. Maybe we've been missing a big skip, day of skip. But that's not likely, because I'm keeping a couple CB radios playing quietly all the time in my house now, so I won't miss the skip, which appears sometimes to come and go really fast, like maybe in 15 minutes. So the moment I hear Alabama calling, I'm running in here. I can't. I have no antenna. So we'll do a couple of antenna experiments. First, we're going to start with this here dummy antenna. This is the one I measured at 50 ohms, RF power. And we're going to check the, according to this meter, the standing wave ratio into the resistor. If the resistor is consuming all of its energy, all the energy that's coming to it, no reflected power, should see a really good we won't hear skip because we're listening to a little resistor. RF power. First for a check, make sure we're there. What channel are we doing this on? Channel 15. There we go. We got our 1 watt on here. I got something going on the oscilloscope there. So I do have the pickup coil. This is my pickup coil, which is a coiled up clip lead. Not quite quite as well engineered as the one in the book. Here we are. Nice. I like it. I like that. So we'll flip this over to SWR Calibrate. Last time I tried this meter sticks up around here. Yeah, it's sticking. Okay, so it's not quite properly calibrated. It's almost at the limit of the calibration control anyway, because the RF power is low, I think. SWR. Hey, that's a little different than that. That is a little different than what happened last time. Maybe the problem is in this meter. Okay, let's try SWR meter number 2. Well, first, while it's on field strength, it's just barely coming up. And that could be because, hey, I'm just into this resistor, or maybe this SWR thing is real, and most of the power is just going back into the radio. A good deal of the radio will act as an antenna, you know, just going to shoot the signal out to, you know, in this kind of close proximity. No, you know, this is normally in a metal cage. This whole thing comes with its own Faraday. It comes with its own Faraday cage. Seriously, that's not on. God only knows what's happening in here. SWR power. It's just barely knocking it up, but then, well, we can try this again when I have the antenna connected. Wouldn't that be a great idea? But I want to try this on SWR to see if it matches this meter. Lots of snow coming for Aurelia. There's a lot out there right now. It's going to snow all day today, a little bit, but tomorrow apparently is the big snowstorm. So I already got about, I don't know, a foot and a half of snow out there maybe. Okay, so now we're going to look at what this one says for SWR. Doesn't appear to be any calibration on this meter for SWR. Not like this other one. There we go. Well, it's also going out. So what has changed? Why is it previously this meter hardly moved? I'm just looking everything over. Well, one thing is I got this in here. I can't imagine that. Is that doing it? No, of course not. Other equipment I have connected cannot really be causing a problem, I'm pretty sure. Let's put this guy back in here. So, let's just for interest and excitement, let's try the other dummy antenna. This, I believe, has a resistor whose value is 75 ohms by measurement. 70, 71, something like that. Things got really quiet this time. Look at that. Hear it? How come it didn't go quiet? Did not go quiet. I'm not saying anything at this point. It's just that. sometimes, I'm going backwards sometimes in this shot. Wait a minute, how come that's jumping around a bit? Probably a momentary short. How come everything's happening here? How come this looks this way? Once again, SWR eating all the signal. Gobbledygook. Nothing coming back. I didn't even have it hooked up properly. I didn't have it tight. That's okay. This guy doesn't do anything. What to think here? Hey, let's put the antenna on. Why stop at this point? More confusion is available. I never did transmit with this antenna yet. Okay, we'll try and do that later. But I'll tell you what the result is because I have the feeling I may not do it. Using the signal generator, looking at it on the SDR, tuning the signal generator all the way through the CB band and way high and way low, halfway, double the band, all that. The impression I get is there's ever so slightly something going on with this antenna, that it works slightly better around 27 megohms. So in other words, they put that into a finished. I can make a Finnish statement. I'm Finnish. Well, I'm Swedish. Well, I'm Canadian. Okay. The final statement on this antenna is slipping my mind now after that little. Okay, let me think. Let me just settle myself down now and think. So I have the antenna hooked up, but I don't have the antenna hooked up. I have the antenna coil hooked up. SWR. It's about the same as the 50 ohm resistor. So you can see they've colored in a meter here to show red. If your SWR is up in the red, they're kind of suggesting that's a bad thing. There comes a point where if you're putting out enough power and enough of it is reflecting back, right, you're just going to overheat the output of the radio. This is a tube radio, so I don't know if that's really a serious problem. I think it's a much less a problem with a radio like this than with a transistorized radio. And I guess you could also, if the resonances are just right, you could generate very high voltages back here too. I think. I don't really know. I am not a radio designer. So when I key this and it goes up into the red, I'm saying to myself, well, I can probably get a couple of minutes, or maybe not a couple of minutes. Maybe, just thinking about how fast things heat up, how long it takes them to get to top temperature, and things like that. If it's not a voltage issue, it's a heat issue. We got some time. Some time. Well, it's not as bad as I thought. I'm sure I saw this thing whack right over solid using this antenna. Next thing is this antenna is really close here. I mean, it's right here. I really should have an extended cable, and I could do that. You know what? I can extend this a mile. I can extend this way out to the front of my house even. More interesting experiments coming. Actually, getting it extended out here some distance is a good idea, so I think I'm going to work on that later. today, fooling around. Let's compare these two meters again, because I want this meter for its field strength feature. Even though I'm not making much use of it yet, but I think at some point it might become quite valuable that way. So let's try this guy back in here and see if it gives the same kind of response here with the antenna. Remember all the things that are wrong with the antenna. No ground plane. No ground plane is the main thing. I think that's wrong. I need to bring a car in here and stick the car underneath the antenna to make this solve that. Here we go. What do we get? So we're on RF power. Not quite a watt. Again, calibration. No can do. Reading. This one goes right over. That's what makes me nervous. What do we got up on the scope? And what does the scope show? Okay, I'm going to talk into this. We're going to see if any modulation shows up on the scope just with my voice. XM 43, 51, 52. Yes, it does, but it's a little hard to see like that. So I will put my camera over here. You get a better look at it. We'll see, it will fiddle around a bit and just see what kind of result we can get without burning up the radio. Change the lighting here. Okay, I will key the mic. Okay, something different just happened. I'm sure you heard the squeal. Why? Here we go. That's better. Okay, so I don't know what happened with that squeal just now. What was that? What was that? That's I don't know. Okay, I'm gonna talk. XM 43, 51, 52. XM 43, 51, 52. So you have to look very, very closely at the scope and watch for any single line spots that show up in the fluttering display. I can change the scan rate too. We'll see if that makes it easier to see, but it's tricky. I think you can see moments of 100% modulation in there. That's what I want to say. XM 43, 51, 52. So you have to yell pretty loud. In fact, unnaturally loud yelling to get that effect. Let me talk like I would talk if I was calling somebody in Alabama. Breaker, breaker, 1-5. We're calling for Alabama. Okay, got a little carried away there. I can't help myself. So I saw some pretty strong modulation on there. So we could go through the modulation test, feed in an audio signal, and watch this and see if it doesn't modulate right. I think that's a really worthwhile thing to do. To do it in a more quantitative way. And wait a minute. Oh, I hope nobody came back on that. I had the volume down. If I only knew somebody about 4 doors away on the street who has a CB radio. Because I think 4 doors away is about as far as I'm going to get with this little antenna. Alabama, you guys can relax for now. I'm not coming for you yet. So I'm going to set up for that oscillation test. I think that's what we should try. Great. Okay, let's see how confused I can get now. So I have a signal generator, this one here, you can barely see it back here, putting out a fixed frequency of about 1,000 hertz. You can hear it. On the oscilloscope, I have both channels showing now. The upper channel is RF. You're not going to see anything here until I hit the transmitter. And this is showing what the speaker is producing. This is right on the speaker connections, which is why you can see something there. The statement in the manual is if I feed in a 0.00, I've done this, tried this, 0.0025 voltage signal here, very, very low level, into the top of the volume control where I'm feeding it in. Then with the volume open wide, it shouldn't be too hard to see 2.5 volts on this meter. It's a little hard to see it right now because of that there. So 2.5 volts in a little speaker like this is pretty darn loud. So I'm going to turn down my shop mics a little bit, and then I'm just going to crank up the volume until I see this meter pop up in this area. And there'll be the cats in my house will have their ears pinned back when this is finished, I'm sure of it. So down on the microphone volumes here. Okay, first, without transmitting, just feeding in the signal in the audio as I'm supposed to do. So I gotta watch this meter, see it get up to here, look on the scope, see if anything's distorted. That's the idea. Here we go. So from my perspective, that test indicates things are really in good shape. I think so. I got this thing all really showing 3 volts here. Right? I'm on the 10 volt scale, so 10 volts is up here. Double checking everything here. 3 volts. I got 3 volts on that speaker. That's for sure. Speaker sounded like 3 volts on it. Really quite loud in here. Way louder than you would ever have it in normal use. And at that point, very little distortion. They crank it up even higher, and you can start to see that odd wave shape they were talking about. So it tells me the audio limiting is working, and it seems to indicate everything's great on this guy. So now we're supposed to transmit with this signal, but it doesn't describe clearly in this part of the test instruction of how to do it. You're supposed to transmit the 1000 Hertz signal and look at the kind of modulation you get coming out of the antenna. I'm feeding this signal into the audio circuit. I'm guessing it's the same circuit that's used with the microphone when you transmit, but I don't think it's working right. So so here's the deal. If I hit the transmit, you can watch the scope here. Really can't explain why the bottom one is showing RF, but it is. So I think we'll just kind of ignore that fact. The bottom one is audio. Probably what? Probably there's a lot of RF in the audio. You can see my connection here. Here's the scope lead. It's just connected to to the same terminals that this meter is. It's connected to the terminals of this meter. And the meter is connected to the speaker voice coil. So what we see on the lower trace of the scope is what is arriving at this point. Now, I mean, there's so much RF in here. Let's do this. Let's get off that antenna. That's probably part of the picture. I'm going to put in the 50. The 50 and the antenna work the same. And that kind of reassures me the antenna is actually producing a 50 ohm. It's producing 50 ohms. Is 50 ohms. It doesn't produce 50 ohms. Okay, now back on power. Watch the scope. Yeah, see how much the lower thing is reduced? I'm willing to bet if I rearrange the test leads in here a little bit, I can reduce it even more. But I think that RF in the audio signal is just being picked up in my shop. It's not an indication of the radio's operation really at all. So we should see the audio on the bottom and the RF on the top. Good. And I think there's still 1,000. Still 1,000 hertz signal being fed into the amplifier, but I don't see it at all in the output. I'm going to crank it up, see if it shows in the output. then the only conclusion I can reach after that, if I don't see it, is the audio signal has to be fed in somewhere else, and I haven't found it anywhere in the manual where it says where to feed it, which is why I'm doing some of this stuff right now. Okay. Up with the signal, up with the 1000 hertz, which is really quite low right now. So I saw absolutely nothing. Actually, just at the very end, as I let go of the button, you saw a moment of it, I think. It looks like feeding this audio signal in at this point, although you can hear it on the receiver, it's doing nothing for the transmitter. So I'm going to stop. I'm going to read that manual a little bit carefully. Once again, not a little bit carefully. I've read it many, many times now. And see what I missed about where to feed in the audio signal during this test. Okay, so here's the story on how the audio is going through here. Take a look at this. On receive, opens cathode of first speech amplifier V10. So microphone will not feed through to the speaker. Grounds one end of speaker voice coil to place it in the circuit. This is what's going on in that switch on the microphone. Notice it's a ceramic microphone, which explains the tonal quality of my voice when we heard it. A ceramic microphone produces a high level of voltage too, by the way. Grounds one end. Opens cathode of transmitter oscillator and amplifiers V1, V8 to turn them off. So a lot going on when you push that button. This is the part I really wanted to show you though. To transmit, when you click transmit, grounds cathode of first speech amplifier VB10. So microphone will feed through to second speech amplifier. So what's going on there is this is kind of a selection of where the audio is coming from. Is it coming from the microphone or is it coming from the radio receiver? And when you hit the microphone button to transmit, the receiver audio is cut off. And the microphone will feed through. We can see this. There, it turns on these tubes. There's a lot of stuff going on in here. Relay operating. Let's go look at the schematic now. So this is the tube we want to look at. This is V10, B and A, so 2-part tube, 12AU7 audio amplifier tube. Here's the microphone. So let's zoom in here. Here's the microphone. There's the switch, transmitter, receive, and the audio is fired back straight to the grid. The radio audio is coming up this way, coming up on this side. And if I read it right, when you click transmit, this part of the tube is cut off in some way, so no radio audio can carry on through, and instead the microphone audio is allowed to pass through. See, ultimately you get to the same point here. Carry on in the radio, where they carry on quite a distance, obviously. So anyway, it's got to go all the way back to the other side of the schematic, the way they've drawn this. So that's the story. So if I want to feed 1000 hertz signal in here, I got to do it here, like from here, or maybe on this pin, or you know, back behind this capacitor, if I can spot this, feed in audio. I could do it down on the switch here. Just feed it in on here. If I fed it here, it would show up on receive, and it would also show up on transmit. No, it wouldn't show up on receive. Yeah, I don't quite get this connection on receive to the microphone here, but that's a ground wire. That's what it is. So it's grounding this. Puts a ground on here. Sure, you know, I don't know what I'm talking about here. Never mind all that. I don't know what I'm talking about, but it's true. I do have to feed the signal in here somehow. Back away from the grid would be better. Here would be the best. Right where this wire. If I can find a wire, the non-grounded wire, that's ultimately connecting to, it's coming in, hitting a capacitor, resistor, and going to pin 2. Okay, time to hunt that down. Okay, let's get the close-up camera going here, and see what we can find. Can I remember what I'm looking for? No. Yeah, so here's the microphone wire coming in, and you can see there's a red wire, a white wire, and a black wire. The red wire is disappearing up there somewhere. And the black wire is heading over here. The terminal I'm putting right in the middle of the screen here, if I can do it. Okay, so it's kind of far away, but roughly the middle of the screen is where you should see a black wire coming in there. Is that grounded? That's what I'm trying to spot. I don't think so. Looks like there's a could be a capacitor connected there. That brown one down on the bottom. Okay, so we follow the other wire. The white one, well, it's coming right in the same area. It looks like it's hooking up. Looks like it goes through a capacitor. Hey, you know, that would be the guy, wouldn't it? It's going through a capacitor. Hold still. 0.005 capacitor, and then right into a resistor there in series, and then down to a tube pin. Well, that sounds like what I saw on the schematic. So white wire could be the one. Let's double check. Getting a little late in the morning here for me. I got a late start today too, so just about time to stop for lunch, in fact. Yeah, because I'm having trouble concentrating at this point. Yeah, real trouble. Where's that white wire going? So we do want to look in here. So you don't white, hua, hua, ra. No, that's receive and transmit. I think this is white. Capacitor straight to a resistor. That's it. So we feed audio in there. Now, is that going to somehow damage this microphone? No, but a microphone might produce the sound from the signal generator. That's the spot to hook up where the white wire is. That's it. Okay, so you can still see the close-up camera there. But I'm going to move it because there's nothing too interesting there. This is where the interesting stuff will be. Okay, now I got to make the connection to feed the audio into that point. I'm going to do it through this protective capacitor I'm already using. I'm going to pull this off the volume control here. The radio's operating, so I need to be pretty careful. Heard a little tune there. I think I bumped the center post. So we'll make sure this is down because we're talking about a microphone here. So the output level is low on this wire. And we'll hook this up where that white. Oh my gosh, we will, eh? Okay, a little bit too much light here for the camera, I'm sure. Actually, you know what? That's it. It's on a terminal. It's on a terminal post, a terminal strip. Excellent. I'm going to unhook that. I'm going to go in straight beside this green connection here. Make sure I don't do anything bad. You know, unless the radio's in transmit, this shouldn't do anything. And now we will hook up the. This is the audio output. Yep. Close there. Boom! You scare anybody? Okay. So now we think we're feeding a 1000 Hz signal into the microphone. So on a key to transmitter, the 1000 Hz should be transmitted, and we should see it up on the scope here on the upper display. The upper display is the one that's showing the RF being picked up by the yellow coil. Is that all straight? Everybody with it? Just need a little more light here to help the camera out. Let's try this. Right here. Yeah, that's not so bad. Okay, so right now the 1000 Hz signal is low. What do we get? Okay, so I still see some RF in here, but I don't see any audio. You know, I could get rid of that RF with a capacitor. But I won't do that just yet. If I talk into the microphone, ooh, okay, still something coming there. The output impedance of the signal generator is very low as far as I know, 50 ohms, so that should be killing this little microphone. It appears to be doing that. Let's raise the signal level while the radio is in receive. See if it shows up. It should not. Okay, give it a bit of a blast. A little bit. A little bit there. Okay, now we're ready on transmit. I gotta transmit. I gotta put my hand. I gotta hold this electrode. I gotta reach over to this thing. I gotta watch out grounded stuff here and there. Frankly, I don't think it's very likely to get a shock off this, but I don't want to find out. I don't want to find out. So all plastic knobs in that here. Okay, now I'm gonna watch the RF display and make sure it's not over 100% modulation. That's my first objective here. Don't go over 100%. Here we go. I'm nowhere near it. So the ceramic microphone can produce, I'm going to guess it's just like a ceramic record cartridge. It can produce a volt of output. I don't think we're anywhere near a volt of output on this. Let me talk into here. We'll calibrate this lower line. No, turn it like that. How big is that? How big? Oh, I know, I got the 1000 hertz there. Is there anything left of my voice? Not really. Very, very, very small. Let me disconnect the wire, the audio signal thing for a sec. Okay, see if it's... Hello! That's a little better. Saw some flattening down here. XM43, 5152. Definitely flattening down here. I think that's a problem. Am I the cause of this problem? Or is that what's really happening on the radio? In terms of my voice level on that was really quite normal. That's how people would talk into this radio. Let me watch the upper one. I haven't really watched it. XM43, 51, 52. So on the loudest peaks of my voice, this does appear to be getting right down to about 100% modulation. Okay, bearing that in mind, we've discovered that something is maybe not biased right. It's giving us that flat stuff. Let's go back to feeding in the audio signal. Now, supposedly this thing has automatic clipping, so we shouldn't have to worry about overdriving this guy. I don't really know what that even means. Well, I think we know where a lot of radiation comes from. It comes out of this box. Is it? Wow. These are bad actors. I was reading on a website that said, go ahead and use one of these to maybe help you trim your antenna, but then get it the heck out afterwards. I can see why. This is a cheap thing. You can probably buy really high quality meters that really you could leave in all the time, but this... clearly a bad actor. And again, I'm sending all these signals here right in my shop, right next to the radio. No shielding on the radio. I could be doing all kinds of bad, weird stuff. XM43. Hey, where'd my audio go? Could I put this on here? XM43, 51, 52, trying all kinds of weird stuff. Yeah, clearly you're getting a bottoming out here. By the way, if this is blowing off my video audio, I'm sorry. I don't listen to the audio as I'm doing this. Okay. Lots of okays. Feed in that audio signal now. We're ready. I think I'm ready. Here we go. Now that was really interesting. Here's what we got. Distortions and over 100% modulation. Power, same as always. PA current. We haven't been watching the PA current. Volts. Okay, so the PA current, what was it, 10 milliamps per volt, 22 milliamps target, 13 milliamps minimum. 13, is that voltage? 13? I can't remember. What is it? 1.4 volts. So that's 15 milliamps. That's really not a risk or concern, so that's good. This thing will even do modulation. Let's give it a try. It claims to do modulation. Has a calibration. Okay. Modulation. How does it do this? Take off the audio. Hello, we're testing, and it looks like it's telling me the percentage gets up to 50. 50 on a somewhat damped meter, so maybe 75. So I gotta repeat this now, exactly what I just did looking at the scope. Okay, we're looking. Yeah, for sure there's over 100% modulation on the scope. This guy doesn't really show it. Okay, back to putting in the signal, controlled signal. Watching this, watching this. Let's watch this. I'll set the audio signal high enough to bring this to just under 100% modulation. Just below 100%. Hopefully there'll be no distortion here. Maybe there will be. And we'll see what the modulation says here when we get to there. Okay, so here we go. So first, upper one, 100%, lower one, look for flat spot, then check meter to see percent modulation according to my $1 meter. Okay, here we go. Okay, 100% right about there. Distortion at the bottom. Modulation running at exactly 100% on this meter. Oddly enough, this meter goes up to 120% modulation. Okay, I guess you can measure that. So at 100% modulation, we're getting. Now I'm going to key the transmitter. I'm going to reduce the signal until the audio distortion disappears in the lower line here. The flat spot goes away. Be about there. Now what do we got? What was that? I don't know what that is. Modulation now about 40% on this meter. So I'm looking at the scope at the upper display. Is that 40%? Kinda. And okay, so that's kind of balancing out fairly well. Now let's look at the audio signal on the scope, the lower line. Look carefully for the shape. And I'm going to suggest to you that the lower part is more pointed and the upper part is more rounded. So it looks kind of, I don't know what, guitar pickish. So I think that's sharper than this. Now you look at this upper one, which is supposed to be nothing more than a reflection of this audio signal. So try to ignore the fact that it's doing this and just watch the upper line and see if it matches this. I don't think so. This looks, it looks like waves. It looks like waves coming across here. But it certainly is distorted. We have distortion in the transmission audio. I don't think I saw that in the receive audio. Pretty hard to compare the two. So what is this showing me? showing me that something is probably not biased correctly in the audio circuit. That would be my first guess, that we have a tube with a characteristic curve and you want to operate it in this flat area, but unfortunately, because the bias is wrong, it's either up too high or down too low, and so it's swinging around. So part of the wave is in the flat area and the other part of the wave is in the curve, and that's what's given us that guitar pickish shape, if I can call it that. Maybe that's not the best word for it, but so how do we figure that out? Well, there's a whole bunch of tests listed in the manual for checking for this kind of stuff. So I think from here, that's where I'll go next. We'll just leave the antenna as an open question. We'll continue to fool around with the audio quality. We're on our way to discovering if biasing is correct, which may lead us into weak capacitors. Who knows? I haven't changed any parts in this thing yet. Not a single part. Wow. Well, lots of fun without having to do any work. Sort. Okay, I think that's it for today. It's, wow, it's afternoon already. And I gotta go look at the snow. Thanks a lot for tuning in, switching in, selecting in, whatever it is you did. And I'll see you on the next video. We'll look more closely at this audio distortion question.